On today's episode, Volkswagen doubles down on batteries, piggyback airplanes for downtown-to-downtown interurban transportation, and turning CO2 into blue ammonia. Today's episode is brought to you by Engineering.com, a globally trusted source for engineering content. Check out this and many other exclusive videos for the engineering professional found only on engineering.tv today. We all know that to fly a rocket into orbit is done in stages. A booster stage lifts the second and upper stages into the upper atmosphere, then it's jettisoned to reduce mass. This not only makes orbital flight possible, but staging improves performance and it allows higher orbits. Could this principle be applied to air travel? Well, two former SpaceX engineers think so, and co-founders Jamie Gull and Evan McCasey have launched Talon Air, which plans to combine multi-rotor robotic vertical lift with conventional winged aircraft to deliver the advantages of both with longer range and higher speeds. The Talon system is essentially a large vertical takeoff and landing drone, which carries a fixed-wing passenger aircraft as payload. After vertical takeoff from a convenient downtown location, perhaps a rooftop, the stack rises vertically, then translates to forward motion, and the aircraft is detached, flying to a destination city like any conventional fixed-wing aircraft. On arrival, the aircraft meets with another vertical lift drone, which brings the assembly down for a helicopter-like landing. Now, in principle, it's simple. Use the VTOL hardware only at the beginning and end of each flight rather than carry the extra mass city to city. Mating and demating will be automated, and the vertical lift drone is, of course, unpiloted. Projected performance for the system is impressive, with a 350-mile range and a 1,000-pound payload at 205 miles per hour in cruise. That range would be well within the needs of point-to-point travel between many U.S. coastal cities and many others worldwide. Both the passenger-carrying aircraft and the vertical lift drone are battery-powered. Now, the staged aircraft concept, well, it isn't new. Richard Branson's Virgin Galactic carries their suborbital spaceplane to altitude under the world's largest carrier aircraft, and as far back as 1938, the short Mayo composite used stacked flying boats to allow Imperial Airways to offer long-distance service for airmail and a handful of passengers. Now, that system worked, but was made obsolete by larger, longer-range aircraft. The Talon system is unique because it promises to eliminate the complex hardware and software needed by current tilt-rotor designs like the Augusta-Westland Leonardo. But will it all work? Now, the company has generated serious interest and is funded through startup accelerator firm Y Combinator and lists both the U.S. Air Force and the Navy as partners. We'll report back as the project develops. Carbon capture and storage, well, that's one way to address global warming, but another is electrification of transportation. Batteries have long been regarded as the rate-determining step for the electrification of light vehicles, and as EVs increase in popularity, the ability for manufacturers to source batteries at scale and at low cost, well, that's emerging as the most important issue in the transition from internal combustion engines. Stockholm-based Northvolt has announced a $14 billion order from Volkswagen Group for electric vehicle batteries, an order which will require significant upsizing of Northvolt's Swedish operations. The order is part of a larger collaborative strategy to optimize investment in EV technologies for Volkswagen's European operations. As part of the deal, Northvolt will sell its part of a battery joint venture in Salzgitter, Germany to Volkswagen, while VW will invest further in Northvolt. Essentially, Northvolt will become VW's primary cell supplier, while VW will take battery production in-house. It's an important distinction because cell chemistry and geometry is only part of the cost and performance profile of an electric vehicle's battery. How cells are assembled into the battery, plus the hardware and software needed to manage charging and discharging, well, they're as important as the cells themselves. For Northvolt, the VW deal brings their order book to $27 billion from key customers, giving the company the ability to lower costs through scale economies, while for VW, the automaker can develop proprietary battery solutions with tight control over their IP. That's not just a matter of protecting patents. The ability of electric vehicle manufacturers to differentiate their products in a crowded marketplace will depend more and more on the two most critical attributes of electric vehicles for consumers: range and charging speed. With global battery capacity increasing exponentially, it's clear that the market for electric vehicle batteries will not evolve the way semiconductors have. Each continent's automakers will have access to local supplies, although they may also use cells or packs that are outsourced globally. To address climate change, there are really two approaches: emit less carbon dioxide or sequester and store the CO2 that's already in the atmosphere. While a great deal of attention has been paid to the former, carbon sequestration and storage, well, it's moving forward as well. And this week, oil and gas production services heavyweight Baker Hughes has signed an agreement with Norwegian carbon tech startup Horisont Energi to develop a carbon storage project off the north coast of Norway called Polaris. The two companies will develop and integrate carbon capture, transport, and storage by production of blue ammonia. The Polaris project is expected to have a total carbon storage capacity in excess of 100 million tons, which is twice Norway's annual greenhouse gas emissions. Construction is expected to begin in the second quarter of 2022. A key goal in the Polaris project is low cost, low enough in fact to make storage that is not only independent of government support, but is profitable. The two companies are also collaborating on carbon sequestration projects that leverage existing drilling technology in well construction, especially in the subsea area. Now, at the present stage, the firms will develop front-end engineering and design activities and model the service life of carbon storage projects, from site selection, drilling, and power to subsea infrastructure. On the hardware side, the deal will include development of high-efficiency turbo machinery, including compressors and turbines for syngas, steam, CO2, and air. The combination of sequestration and blue ammonia production may allow net zero CO2 emissions while retaining some portion of the existing fossil fuel industry as we currently know it. It's an important project, and we'll keep you posted. Well, that's it for today's episode of This Week in Engineering, brought to you by engineering.com. If you like this show, be sure to subscribe to our channel and click on the notification bell for our next episode. For deeper engineering content, visit engineering.tv for exclusive shows like Manufacturing the Future and Designing the Future, not found on our YouTube channel. Thanks for watching.